Our fourth step is to find our p-value. And it's important to realize that what the p-value is telling us is that, okay, if your assumption's true, what are the chances you got the evidence you did? To calculate the p-value, we're going to need our z, or our normal table. And that is, once again, if we're doing a one proportion hypothesis test. To find our p-value, we'll take the following steps. The first thing we're going to do is we're going to go ahead and draw our bell curve. The next thing we're going to do is we're going to place our z-score, that is our test statistic, on it. Third thing we'll do is we'll shade. We're going to shade depending on our alternative hypothesis. That is, if we had our alternative hypothesis and it said greater than, then we will shade above wherever our z-score is. If our alternative hypothesis was less than, we'll go ahead and shade below wherever it is. We'll add a third option, which is not equal to, later on. Now, it's important to realize here that the z-table itself only gives us lower end tails, which means that if we're doing one of these, let's say greater than, we'll have to go ahead and look at our negative of our z-score, or take 1 minus whatever probability we find from the table. These are the steps we're going to be following, so let's go ahead and do an example for it. Now, for our first example, let's say we have the following information. Let's say we were given HA is P is less than 0.17. This is like we're trying to show whatever is less than 17%. And we were also given that our z-score is negative 2.15. When I go to do step 4 then, this is the only real information I need. I start by drawing my bell curve. After I draw my bell curve, I place my z-score on it. Because my z-score is negative, I'm going to put that on the lower end. It's below my expectation. So I'll put my z-score right here. Once again, on the lower end because it's a negative z. I then shade depending on what my alternative hypothesis was. In this case, I want to show that it is less than, so I'll be shading below. Lower end because the z is negative, below because it's less than. The next thing I need to do is go ahead and go to my z-table. So let's move down a little bit and put it in here. So, moving my z-table down here, what I need to do is realize, first of all, that because I'm looking for a left end tail, I could just use my z-table as is. Knowing that, I go to the negative side of my z-table, like I put in here, and I try and find my z-score on the table. I have negative 2.15, so I'm going to go to the left side, and I'm going to try and find negative 2.1. That's right here. I need negative 2.15, which means I go up to the top and I find where 0.05 is, and I trace it down. Where those two overlap, that is going to be my p-value. So, in this case, my p-value is going to be 0.0158. This is like saying, okay, if my assumption is true, if exactly 17% of people feel this way, there's only a 1.58% chance this would happen. That's a pretty low percentage. Let's go ahead and do another one, though. For our next example, let's go ahead and say that we were giving an alternative hypothesis of P is greater than 0.85. This is like trying to prove over 85% of people feel some way. I'm also going to tell you that Z is equal to 1.02. To find my p-value, I would draw my bell curve. It's a pretty ugly bell curve, actually. And then I'd put my z-score on it. My z-score is 1.02. If this is the center right here, that means I'm right on expectation. My z-score of 1.02 is above that because I'm above expected. So I'm going to put my z-score right there. Top half because it's positive. Next thing I'm going to do is I'm going to go ahead and shade it. I shade above because I want to show it's greater than 0.85. So we'll shade over here. Now I've got this, and the next thing I need to do is realize right off the bat that my z-table is not going to give me that. And the reason is the z-table only gives me left and tail, or cumulative probabilities. So if I find 1.02 on the table, it will give me this percentage. I don't particularly want that. So instead, what I'm going to do is I'm going to look at z equals negative 1.02 instead. What that will do is it will find me this end tail instead, but because the normal distribution is symmetric, those two will be the same, so I'll have my percentage I want. Let's go ahead and insert in our table here. And look at this again. Now looking at negative 1.02, I'm going to again trace it over. Negative 1.0. I'll go ahead and trace 0.02 down. And where they overlap, that right there, will be my p-value. So our p-value in this case is 0.1539. Now let's say that we didn't want to go with the negative 1.02. That is, we wanted to use our original z-score. Well, we could do that as well. Let me go ahead and put our positive z-table in here instead. If I go to find 1.02 on this table, I look at 1.0, and going down 0.02, then my overlap is this 0.861 there. Remember, this is not actually giving me the end tail I want. Instead, what it's saying is that this area over on this side, this entire lower half here, everything below a z-score of 1.02 is 0.8461. If I wanted that blue side, then what I would have to do is take 1 minus that. And if I took 1 minus it, notice, sure enough, I'd get the 0.1539 I was looking for. This has been 2 examples on how to go ahead and find our p-value if we start knowing our z-score and our alternative hypothesis. Notice that when we do this, we really need to look back at step 2 in order to get what our alternative hypothesis is, and step 3 to figure out what our z-score is going to be.